You know, every single day we live our lives on top of ground that we just assume is solid. But what if I told you there's an invisible ingredient under our feet that holds our entire world together or can make it all fall apart? We're talking about soil moisture, and believe me, it's way more important than you think. So let's just think about that for a second. What is the hidden ingredient that allows a massive skyscraper to stay standing or a bridge to handle thousands of cars a day? It's not just concrete and steel. The real secret is in the dirt, and specifically, how much water is mixed in with it.
Okay, so let's get into it. To really understand what's going on with that hidden ingredient, engineers have to do something that sounds almost ridiculously simple. They weigh the earth. Well, small pieces of it anyway. And that one simple act is the key to making sure the ground beneath us is safe and strong.
And here's why it's such a big deal. The amount of water in the soil changes literally everything about it. See, if it's too dry, you can't compact it properly to build a road. But if it's too wet, the ground gets weak and can't hold up a heavy building. We're talking about a delicate balance that affects everything from how water flows through it to whether a skyscraper will slowly sink over time. So to get that balance just right, engineers need a number. They can't just kick the dirt and say, yep, looks damp enough. They need to know the exact moisture content. But what does that term actually mean? Now, the official definition sounds a little textbooky, right? The ratio of the weight of water to the weight of the solid particles. All that really means is, if you took a scoop of dirt, what percentage of its weight is just water compared to the weight of the actual solid dirt particles? That's it. And this little diagram is the perfect way to picture it. Soil isn't just one solid thing. It's actually made of three parts: the solid dirt particles, and then in the little gaps in between, the voids, you've got water and air. If those gaps are full of air, the soil is bone dry. If they're completely full of water, it's saturated. The moisture content just tells us exactly where we are on that scale. And it all comes down to this super simple formula. This is the recipe. You just take the weight of the water, divide it by the weight of the totally dry dirt, times it by 100, and boom, you've got your moisture content percentage. But how do you actually figure out the weight of the water? Well, there are two main ways to go about it. You've got the classic, super accurate lab method that takes a whole day, and then you've got the quick and dirty field method that gives you an answer in about 5 minutes. So let's start with the classic, the oven dry method. This is the gold standard. When you absolutely need the most precise number possible for, official reports or critical design, this is the one you turn to. And this is the main tool for the job, a special lab oven. You can almost think of it like baking, but in reverse. Instead of trying to keep moisture in your cake, you're trying to bake every last drop of water out of the soil to see how much was there to begin with. And the process itself is pretty methodical. First, you weigh your wet soil sample. Then you stick it in the oven at a very specific 110 degrees Celsius and just let it bake for a full 24 hours. After that, you weigh it again. The difference in weight from before and after, that's exactly how much water was in there. Simple as that. But come on, what if you're on a construction site? You can't just tell everyone to stop working for 24 hours while you wait for an oven. That's where the modern, super fast alternative comes into play. Let's talk about the speedy meter. Check this thing out. This device is basically a portable chemistry lab that fits in a case. It's built to be tough, and it's designed to give engineers a really good reading right there in the field so they can make a call on the spot. So how does it work? Well, this is the really cool part. It's not about evaporation. It's all about a chemical reaction. You put a special powder called calcium carbide in with the soil. Any water in that soil reacts with the powder and poof, it creates a settling gas. And the amount of gas it makes is directly tied to how much water was in the sample. The whole process is incredibly quick. You pop a measured sample of soil and the reagent into the chamber, seal it up tight, and just give it a good shake. That chemical reaction starts creating gas, which builds up pressure inside. And that little gauge on the top, it measures the pressure and instantly tells you the moisture content. The whole thing takes like 5 minutes. So now we've got two totally different approaches. One is slow and methodical, but gives you a perfectly accurate result. The other is lightning fast, but maybe a tiny bit less precise. So how on earth does an engineer choose which one to use? Well, this table lays out the trade-off perfectly. It all comes down to what you need the number for. If you're writing the final report for a new skyscraper, you're going to wait 24 hours for that oven dry result.
But if you're on a construction site and just need to know if the soil is ready to be compacted, the speedy meter is your best friend. It's all about picking the right tool for the job.
In the end, it all comes back to this one single idea. We're right back where we started. All this work, the weighing, the ovens, the chemical reactions, it's all because the strength of the soil and its ability to hold up our world can change so dramatically depending on how much water is in it. This one little measurement is a cornerstone of safety in our modern world. You know, this simple test is performed thousands of times a day, all across the globe. It kind of makes you wonder, doesn't it? What other invisible science, what other simple but absolutely crucial measurements are silently working all around us just to keep our world from falling down?